Hi everyone. So today we'll be discussing the problem C from the AtCoder beginner contest 218. So let's see what the problem statement says. So the problem says that you have been given two figures S and T, where S and T are both two-dimensional grid with square cells. So this is the proper grid, 2D grid with square cells, and S lies within a grid with n rows and n columns and consists of the cells where Si, j is hash, and T lies within the same grid with n rows and n columns and consists of the cells where Tij is hash, right? So this is a basic introduction, and determine whether it is possible to exactly match S and T by a 90-degree rotation or a translation, right? And for this you have been given n as n is less equal to 200. So you can see that this is the since the constraints are very low for this question, so you can easily do a brute force on this question. And for each test case, S and T will be hash, and each of the S and T will contain at least one hash. So this is one additional information that has been given to us, and the input format will be like this. So you will be given n, and then you will be given the structure of S, and then after the structure of S is over, you will be given the structure of T, and you have to print yes if both S and T match by 90-degree rotation or translation. Otherwise you have to print no, right? So let's try and see this test case. I'll copy this test case and then let's paste it here. Yeah, so let's discuss on this problem. Yeah, this is the test case, as you can see. So this is what we'll try to do with it. So let's say that for this test case, let me first of all 1 2 3 4 5. So this much part is S, and then the rest of the part is T, right? So what happens is, for this test case your answer will be yes. And do you know the reason why? Because you can notice that in this test case, what can happen is you can translate your S to T by rotating it 90-degree in the counterclockwise manner and then translating it. So how we will be doing it? So first of all, you can see that what is S? You have S as this, and then you have two dots, then hash, and then again star, then dot, hash, then again hash, then again a hash, and then you have a star, dot, and then you have dots, right? So in this manner the structure is, I have just shown you in a magnification manner. So what you will do is, first of all, you do nothing, just simply translate it. What do I mean by translation? So now my new my new grid will look something like this. I'll show you. You have 1 2 3 4 and then 5, and then you have I have moved this uh, one indexes ahead. So what it will look like is this. I'll show you quickly. This is something that it will look like. So yeah, dot, and then hash, and then hash. We are moving it one towards the right. Each cell is moving one towards the right. So what will happen is, again these dots will be there. There will be no effect on these dots since they are dots. So you can see that our structure looks something like this. So you move one to the right, that is you translate, and then you will get this structure. And after you get this structure, what you do is you just simply rotate this structure, rotate this S, rotate this S by what? You rotate this counterclockwise, and after you rotate this counterclockwise, like if I want to show you, so this is the structure that you can see that I am trying to uh, show you. So for this structure, you can see that here you have this kind of a structure, this. structure here. And if what you will do is, if you will simply rotate it like in this manner, if you rotate this like this is this, and if you rotate this, so what it will look like is, it will look like 1 2 3 4 5, and then yeah, so 1 2 3 4 5, and then 3 dots here, then again 3 dots here, 1 dot here, then another dot here, and then for the last one you have a hash, for this one you have a hash, for this one you will have a hash, for this you have a hash, you will have a dot for this, you will have a dot for this, you will have a dot for this. So this is structure. This is structure. What this structure looks like is, this S is has now been converted into this T. So this S that was here, this now got converted to T. So this was the approach, like but what will happen is, like you will say, like it is quite intuitive to see that how we can rotate and all such things, but if you are if you are trying to implement, then such a thing can be hard. So what you can do is, you can since I said that you can have a brute force, so like if you consider a point, if there is a point P at an index x comma y, and let's say you translate it uh, like this, you translate it towards the right, so your x coordinate won't be changing, but since your x coordinate is the same, since you are moving in the same horizontal line, so your x will not change, but your y will become y plus 1, right? So similarly, if you are rotating it by 9, and this will happen for all the indexes, like if you generalize x and y, then for every x and y, this will be happening, that they will be shifting towards the right. And in case if you say that it will go out of the matrix, so out of the cell, so that is not the case, because it will come like here, right? So just imagine this. So what I have said is, you have to apply, you have to generalize it in such a manner, and once you are at a particular cell, you need to check for that cell, you need to check, like you need to consider a particular, for a particular x and y of the your cell S, you need to consider a pair of x comma x dash comma y dash in in the grid T. And in that case, what will happen is, you will try to have a brute force, like for that particular, you will have that pair fixed, and you will try to check, like is every other pair, is everything the same, like if you are considering x and y and at that place. So if x and y are changing, like in a particular with a particular value, so are other indexes changing as well? And if you find such a case, then you will simply print yes. Otherwise, after the iteration, if you are not able to do so, then you will simply print no. So I'll copy this test case and see if this works on our solution that we have given or not. So what happens is, for this test case it was coming yes, so let's see, yes it is coming yes. And for this, I'll copy this test case again, test case number 2, and I'll paste it, and let's try and run. After this, I'll show you that how the code is running. So right, so it should come no, yes it is coming no. So I'll walk you through the code. This was a brute force code. So what you will do is, first of all, simply just uh, simply declare two grids A and B, and you have you have to also declare columns A and column B, right? And what you do is, first of all, take count A and count B, count of A and count of B as 0. Simply take the inputs, and for every input, if you have a hash, if A of ij is a hash, then you take that value, you add that value in a counter. Similarly, you take the second grid, that is T grid, as input, and if the number of hash values in A is not equal to the number of hash values in B, then simply print no and you can return. And in other cases, what will happen is, you can have 4 cases, right? You can have 4 possibilities. So what you can do is, you can use a function is equal. We will be implementing, we'll be seeing the implementation after a minute or so. If that function gives you a true value, then you simply print yes, otherwise you will print no. And each time after the test case is over, then you try and rotate the matrix. So how we'll be doing this? So for this, you have a you have a is equal function, and in that is equal function, what you are doing is, if you simply declare a vector of pairs for a and b, and if your aij is equal to hash, then push it back into the vector of pairs, and if your bij is hash as well, then push that into the vector. And if the difference for a particular index that you have assumed, if the difference for particular indexes is not the same, then that means that your assumption is totally wrong. So that means that if your aij dot first and bij dot uh, first, if you have considered this index, then if for the ith, if you have are considering the ith, then a of 0 dot first and b of 0 dot first should, all the difference between these two should be equal to the difference for the ai dot first and bi dot first. And similarly, if it should not be equal, and if similarly, if this is also not the case, then you simply return and print no. Otherwise you will print yes. And for the rotation part, is pretty simple. I think that everyone who is doing programming knows how to rotate the matrix and all such things. You simply can do what, you can take a matrix C, and then you can store it in a rotated model like 90-degree rotation, and then after that you can iterate once again and you can store the matrix. So this is the problem. So the problem was pretty simple. There could have been more brute force solutions to it, but this was the one that I thought that it is the easiest one to write. So thank you for watching this video. If you like the explanation part, mention that in the comments, and make sure to like the video and subscribe the channel as well. Thank you.